In 2020, astronomers detected an anomalous radio signal originating from the direction of Proxima Centauri b, the closest known exoplanet to Earth. This narrowband transmission, labeled BLC-1, persisted for several hours and possessed characteristics unlike any natural phenomenon or human interference. Although further analysis indicated a likely human origin, its initial detection caused a global stir, leaving many to wonder, what if it hadn't been? Proxima Centauri b is a rocky planet orbiting our nearest stellar neighbor, a red dwarf just 4.2 light-years away. This super-Earth has a minimum mass 1.17 times that of Earth and lies firmly within its star's habitable zone. Despite being tidally locked with one side perpetually facing its sun, scientists believe a thick atmosphere could redistribute heat, making parts of it potentially habitable. TRAPPIST-1e is one of 7 Earth-sized planets orbiting a cold dwarf star 40 light-years distant, with at least 3 firmly in the habitable zone. This specific planet is believed to be rocky, possessing a mass 0.77 times that of Earth, and could harbor significant liquid water oceans. Temperature is estimated to be similar to Earth's, making it a prime candidate for life. TRAPPIST-1f orbits further out in this remarkable system, slightly cooler but still within the habitable zone of its dim red dwarf star. Scientists speculate it might be an eyeball Earth, with a permanent ice cap on its dark side and a potentially thawed ocean on its sunlit face. This world offers another unique scenario for life to thrive on a tidally locked planet. K2-18b is a Hycean world, a mini-Neptune exoplanet 124 light-years away that is 8.6 times Earth's mass, with detected water vapor and hydrogen in its atmosphere. Research suggests it could possess a deep liquid water ocean beneath a thick hydrogen envelope, offering entirely new pathways for life unlike anything found in our solar system. The discovery challenges our standard definition of habitability. Kepler-186f was the first confirmed Earth-sized exoplanet discovered in the habitable zone of another star, found 500 light-years away. This world, about 1.1 times Earth's radius, orbits a red dwarf star, receiving about 1/3 of the energy Earth gets from the Sun. Its discovery in 2014 proved that Earth-sized planets could indeed exist in life-sustaining regions around other stars. Kepler-452b, dubbed Earth-2, orbits a Sun-like star 1,400 light-years away, receiving comparable energy to our planet. This super-Earth is 60% larger than Earth and has spent 6 billion years in its star's habitable zone, providing ample time for life to potentially emerge and evolve. Its age suggests a mature ecosystem could be flourishing there. DOI 700d is an Earth-sized exoplanet orbiting a quiet M-dwarf star just over 100 light-years away, a crucial factor for habitability. It is one of 3 planets in its system, but the only one known to reside in the habitable zone, with a radius 1.02 times that of Earth. Its relatively calm star minimizes the risk of harmful stellar flares. LHS 1140b is a super-Earth about 40 light-years away, roughly 7 times more massive than Earth, orbiting a very quiet red dwarf star. Its star's low activity, compared to other M-dwarfs, significantly improves its chances of retaining an atmosphere and liquid water. This rocky world could possess a dense atmosphere protecting any surface life. Gliese 667cc is a super-Earth located 23.6 light-years away, nestled within the habitable zone of its red dwarf star, part of a triple star system. This planet is at least 3.7 times Earth's mass and receives about 90% of the light Earth does, though much of it is in the infrared spectrum. It represents a potential haven in a complex cosmic dance. Ross 128b is a temperate, Earth-sized exoplanet just 11 light-years away, orbiting a remarkably quiet red dwarf star. Its star experiences very few strong flares, crucial for preserving an atmosphere and protecting potential surface life from harsh radiation. This nearby world is considered one of the most promising candidates for follow-up observations. Teegarden star b is one of 2 potentially habitable exoplanets orbiting an ultracool red dwarf just 12.5 light-years from Earth. With a mass similar to Earth, it receives roughly the same amount of stellar radiation, suggesting temperate surface conditions. This planet's extreme proximity makes it an exciting target for future atmospheric studies to search for biosignatures. Europa, Jupiter's moon, harbors a vast liquid water ocean beneath its icy shell, estimated to be 100 kilometers deep. Evidence from the Galileo mission suggests this ocean contains more water than all of Earth's oceans combined, kept warm by tidal heating from Jupiter's immense gravity. The potential for hydrothermal vents on its seafloor makes it a prime candidate for supporting life. Enceladus, Saturn's small moon, famously shoots plumes of water vapor and organic molecules hundreds of kilometers into space from its south pole. These geysers originate from a subsurface saline ocean that directly interacts with a rocky core, providing the chemical energy and nutrients necessary for life. This active moon is one of the most compelling places to search for extraterrestrial biology. Titan, Saturn's largest moon, boasts a thick nitrogen atmosphere and a complex active cycle of liquid methane and ethane on its surface. It features rivers, lakes, and seas of hydrocarbons, making it the only body in our solar system, other than Earth, with stable liquid on its surface. While alien, this chemistry could support a different form of life. Mars's subsurface offers potential refuges for microbial life, shielded from the planet's harsh surface radiation and extreme temperatures. Radar data has indicated significant water ice deposits beneath the polar caps, and briny subsurface lakes have been suggested beneath the South Pole. These buried environments could sustain dormant or active microbes. Ceres, the largest object in the asteroid belt, displays bright spots within its Achater crater, indicating active cryovolcanism. This activity is fueled by deep reservoirs of briny water beneath its surface, kept warm by its interior. The dwarf planet's geology suggests a dynamic internal ocean where life could potentially exist. Ganymede, Jupiter's largest moon, is unique for possessing its own magnetic field, generated by a liquid iron core. Beneath its icy crust, scientists believe it harbors a deep, multi-layered ocean, possibly sandwiched between layers of ice. This internal heat and protection could provide a stable environment for microbial life. Triton, Neptune's largest moon, exhibits active cryovolcanism, ejecting nitrogen gas and dust particles into space, indicating internal geological activity. This distant moon is believed to possess a subsurface ocean, heated by tidal forces from Neptune and internal radiogenic decay. Triton shows that habitable conditions can arise far from stellar warmth. Pluto's Sputnik Planitia, the heart-shaped basin, shows evidence of a vast subsurface ocean that has likely existed for billions of years. The shifting ice shell and surface features suggest ongoing geological activity, which could circulate nutrients and energy within a liquid water layer. This distant dwarf planet further expands the concept of planetary habitability. Kepler-62f is a super-Earth about 1.4 times Earth's radius, located 1,200 light-years away in the habitable zone of a sun-like star. Scientists estimate it is likely a water world, entirely covered by a deep global ocean. This vast aquatic environment could provide an ideal, stable habitat for complex marine life to evolve over eons. GJ357d is a super-Earth located 31 light-years away, firmly within its M-dwarf star's habitable zone. With a mass at least 6.1 times that of Earth, it is a rocky world that could sustain liquid water on its surface. This close-by system offers an excellent opportunity to characterize the atmosphere of a potentially habitable super-Earth. Wolf 1061c is another nearby super-Earth, just 14 light-years away, orbiting a red dwarf star. It is approximately 4.3 times the mass of Earth and falls squarely within its star's habitable zone, making it a compelling candidate for possessing liquid water. Its proximity makes it a prime target for future telescopic observation campaigns. Kepler-1649c is an Earth-sized exoplanet, only 1.06 times Earth's radius, located 300 light-years away within its red dwarf star's habitable zone. Though its star occasionally flares, the planet receives about 75% of the sunlight Earth does, increasing its potential for liquid water. This discovery highlights the prevalence of Earth-sized planets in HZs. TRAPPIST-1G, one of the more distant planets in the TRAPPIST-1 system's habitable zone, is slightly larger than Earth and potentially an icy world. Despite its distance from the central star, tidal heating could keep its subsurface liquid water, much like moons in our outer solar system. It offers a cooler but still viable path for life. PSOJ-318522 is a rogue planet, floating freely through space without orbiting any star, located about 80 light-years away. Despite the lack of stellar warmth, such planets could potentially harbor life in subsurface oceans sustained by geothermal heating from their cores. This challenges our traditional star-centric view of habitability. The sheer number of potentially habitable worlds we're discovering is staggering, hinting that life might not be unique to Earth. Do you think we'll find definitive proof of extraterrestrial life in our lifetime, and what form do you imagine it might take? Share your thoughts in the comments below, and don't forget to like this video and subscribe for more cosmic journeys.